Okay, so let's talk about limiting reagents, or sometimes they're also called limiting reactants. This is the last little bit of stoichiometry that we're going to go over. So if we go back to my chair example that you guys all loved from last time, to make a chair, you need a seat back, you need one seat back, one seat, and four legs to create one chair. So let's say you're in a woodworking shop and you look around and there are three chair backs, right? And we have, let's say we have four chair seats, and we have 8 pairs of legs, or 8 legs, not pairs. So we have 8 legs total. Okay. Given this arrangement, how many seats can we make, how many complete chairs can we make out of this combination? Well, we know that we can only create 2 chairs. How do we know that? Well, each chair, we need 4 legs per one chair. So 8 divided by 4 tells us that we can only create 2 chairs out of the number of legs we have. We can create 4 chairs out of the number of seats we have, and create 3 chairs out of the number of backs we have. But our legs is what's going to limit us. So since our legs limit us, it doesn't matter that we have 2 excess chair seats or 1 excess chair back. Altogether, we can only create 2 chairs out of the parts that we have. So here's my chair drawing. So our limiting reagent in this scenario, or what limited what can be produced, was the number of legs. So the chair legs limited how many chairs we could be produced. So in this situation, they would say your limiting reagent was your number of legs, or your limiting reactant was the number of legs we started with. So a limiting reagent is the reagent or reactant that is completely used up in a chemical reaction, or it is the chemical that runs out first. So back in our previous example here, we did not run out of chair backs, we did not run out of chair seats, and they were not completely used up. Only the chair legs were completely used up in that reaction. So this is the chemical. So the limiting reactant is the chemical that limits what can be produced. It limits the products that can be produced in a chemical reaction. So let's look at some real-world examples. If we have an equation, say we put aluminum and chlorine together and we make aluminum chloride, how do we do this? So what steps do we actually need to take? Well, first off, just like in stoichiometric calculations, you have to start with a balanced chemical equation. This equation is not balanced. To balance it out, let's go ahead and put a 3 right here, a 2 here. We'll come back and balance our aluminums with another 2 here. Now we have a balanced chemical equation, and tells me that I need 2 moles of aluminum, I need 3 moles of chlorine to produce 2 moles of aluminum chloride. All right, so the problem. Let's say you start with 3 moles of aluminum and 5.3 moles of chlorine. What is your limiting reactant? Okay, so what is your limiting reagent? So how do you do this? Well, first, you've got to, you know your mole ratios that you need, so you need to compare. So if I have 3 moles of aluminum, I know that in order to completely react this with chlorine, I need 3 moles of chlorine per every 2 moles of aluminum. Same steps that we're taking when you're doing stoichiometry. Your moles of aluminum will cancel out, and you'll find out that you need 4.5 moles of chlorine to react with 3 moles of aluminum. All right? Well, right there, we already know that we have more than 4.5 moles of chlorine, right? And the problem stated that we have 5.3 moles of chlorine. So I'm going to guess that aluminum is actually our limiting reagent, but let's just check and make sure with chlorine now. So if I have 5.3 moles of chlorine, how many moles of aluminum will I need to completely react that? Well, let's see. My ratio is a 2 to 3, so I know I need 2 moles of aluminum per every 3 moles of chlorine. My moles of chlorine will cancel out, and this will leave me with 3.5 moles of aluminum. All right, so now we can say for sure which one is our limiting reagent. In order to completely react our 3 moles of aluminum, I only need 4.5 moles of chlorine. In order to completely react our 5.3 moles of chlorine, I need 3.5 moles of aluminum. Well, what did we start with? We only started with 3 moles of aluminum. Therefore, aluminum is going to be our limiting reagent because it will limit how much is produced. The aluminum will be used up and there will be an excess of chlorine left over, an excess of 5.3 minus 4.5. So this is our limiting reagent. So when you're doing your stoichiometric calculations now, you completely ignore this 5.3 moles of chlorine. You don't need to know about it. You have found that your limiting reagent is your 3 moles of aluminum. So let's say this question goes on to state, how many moles of aluminum chloride will be produced when you react 3 moles of aluminum and 5.3 moles of chlorine? Well, again, we found that our limiting reagent is aluminum, so we can ignore the 5.3 moles of chlorine. Just erase this real quick. And we can go on with the steps like we would have previously. So we know that 3 moles of aluminum, we can do our mole ratio. We know it produces 2 moles of aluminum chloride per every 2 moles of aluminum. Carry out the arithmetic here, your moles of aluminum cancel. You have 3 times 1 essentially, and so you know you have 3 moles of aluminum chloride will be produced. Okay, and again, it doesn't matter that we have excess chlorine gas over here because we've completely used up all the aluminum, and once the aluminum is used up, we cannot produce any more aluminum chloride. Let's take a look at one more example here. All right, so here we have a reaction of phosphoric acid plus sodium hydroxide, and it produces sodium phosphate plus water. This is an acid-base neutralization. So again, first step to all these problems is you have to balance the chemical equation. Balance it with a 3 here and a 3 here. Once that's written, we know everything is balanced out. Okay, so how many, question might state, how many moles of sodium phosphate, just draw an arrow, will be produced when you mix, if you add in 1.75 moles of phosphoric acid and 5 moles of sodium hydroxide. Well, our first step, we've got to find which one of these is our limiting reagent. Which one of these is going to limit how much sodium phosphate will be produced. Okay? If we do this, we can look here. So 1.75 moles of phosphoric acid. I know my mole ratios based on my balance equation. I know I need 3 moles of sodium hydroxide per every 1 mole of phosphoric acid. So 3 moles NaOH over 1 mole of phosphoric acid. My moles of phosphoric acid will cancel, and I'll be left with 5.25 moles of sodium hydroxide. Okay, so I know in order to completely react my starting amount of 1.75 moles of phosphoric acid, I'll need 5.25 moles of sodium hydroxide. Well, how many moles am I starting with? I'm only starting with 5. So again, you could check 5 moles and see how many you need, and in order to completely react 5 moles of sodium hydroxide, you'll need 1.66 moles of phosphoric acid. So this confirms that our excess chemical is phosphoric acid. Our limiting reagent is going to be sodium hydroxide. All right? So our limiting reagent is going to be 5 moles of sodium hydroxide, and we can finish off this problem. If I have 5 moles of sodium hydroxide, how many moles of sodium phosphate will be produced? I'll go back up to my equation. I know it reacts on a 3:1 mole ratio, so I know that 1 mole of sodium phosphate will be produced for every 3 moles of sodium hydroxide. Carry out the arithmetic, my sodium hydroxide cancels, and I will have 5/3 of a mole of sodium phosphate. Okay, so tomorrow in class we'll take some more look at these. We'll start working some practice problems and show some demos about how limiting reagents affect reactions. Hope you enjoyed the video.